Hello, teacher. This is Maedras, and my final delivery for the subject. And we are going to talk about electrochemistry and how battery chemistry is changing the car. Um, what are endothermic and exothermic reactions? According to Lindsay et on 2024, an endothermic process involves an absorption of thermal energy, and this means that the surrounding heat from the environment is absorbed by the system and generates a change in matter. Opposite to this, an exothermic process consists on the release of thermal energy and heat into the environment to similarly cause a change in matter. They are opposite reactions, and the changes in the matter they cause can be either physical or chemical. The balance reactions for octane and exodecane and ethanol, according to the webqc.org chemical portal online balancing. These are the balances. We need here 2 electrons. Here we add 16, here we add 3, and that's like basically it. Here we have the reaction enthalpies. This is the octane. It's a negative hence, and it's an exothermic. Here we have ethanol, which is a negative hence, and it's an exothermic. An hexadecane, which is a negative hence, and it's again an exothermic. And the most efficient is the hexadecane, as it releases nearly the double of energy than the octane, and nearly 6 times more than ethanol. The science behind a car ignition is that the energy to start a car and the power it lights primarily comes from the car's battery. The battery stores an electrical energy in the form of chemical energy, which is converted to electrical energy when the car system requires it. To start the car, the battery provides a surge of energy to the starter motor, which turns the engine over. For the lights, the battery supplies continuous electrical energy, which is converted into light by the bulb once the engine is running. The alternator takes over and converting mechanical energy from the engine into electrical energy, which recharges the battery and powers the vehicle's electrical system. Lead acid cell batteries consist of lead PB and lead dioxide PbO2 electrodes, with sulfuric acid as the electrolyte. The overall reactions as the anode and cathode involve the conversion of lead and lead dioxide to lead sulfate and the release of the uptake of electrons. Here we can see a battery, and we can see all its parts until the very end.
Okay, so here we have the reactions. In this case, the anode reaction is oxidation because it loses electrons, and the cathode reaction is a reduction because it gains electrons. This all occurs with the lead, and we can know that a reaction is oxidizing because it loses electrons, and it is reduction when it gains. Then we have the lithium-ion batteries, which the main material is the anode and the graphite because it is the most commonly available. Then we have the cathode material, which is lithium cobalt oxide. Which is now lithium iron phosphate because it is more safe, stable, and has a longer life cycle. Then we have the electrolyte lithium salt in organic solvent, which is commonly used in a solvent such as ethylene. It allows for the movement of lithium ions between the anode and the cathode. Then you have the separator, which is usually polyethylene or polypropylene, which is a thin porous layer of polymer film, which its main function is just to allow the lithium ions to pass through. Then we have the carbon collector, which is aluminum for the cathode and copper for the anode, because they are good electric conductors since the reaction is electric and allow for the flow of electrons. Then we have the lithium-ion batteries, main material, sorry, the reaction, which is again at the anode is oxidation and the cathode is reduction. Oxidation means that it loses electrons, and reduction that it gains. The overall chemical reaction can be written as this, which is exothermic, meaning it releases energy heat as a result of movement of lithium ions and electrons. They have the halogen-based cell batteries, which are mainly based on a hydrogen. The electrodes are a component made of platinum or platinum-based catalyst, which facilitate reactions. Then the membrane, a polymer electrode membrane, such as an naphthalene that conducts proteins while being impermeable to gases. We have the gas diffusion layers, which are common-based materials, common cloth paper, that allow the even distribution of gases and provide electrical conductivity. Finally, we have the bipolar plates made of graphite, metal alloys, or covering metals. These plates ensure electrical conductivity and manage gas and coolant flows. Finally, the reaction is exothermic once again, an exothermic electrochemical reaction in a hydrogen fuel cell. In this reaction, hydrogen gas is oxidized at the anode to form protons and electrons, while oxygen gas is reduced at the cathode to form water. This was a complicated project because, well, we had to do a lot of chemical reactions and understand the lithium batteries, the lead batteries, and the hydrogen batteries. But we know that this is the future. It represents the continuity of using more renewable materials. Hydrogen is the most available element in the universe, and to avoid contamination. Thank you.